Modern production is impossible without a wide variety of machines and mechanisms. Depending on the functions performed, the machines are divided into energy, technological, transport, and information. The main component of any machine, regardless of its purpose and scope, are mechanisms. It is a system of bodies designed to transform the motion of one or more solid bodies into the motion of other bodies. Among the most common mechanisms are lever mechanisms. Crank-slide mechanisms are used in various machines. In engines, crank-slide mechanisms convert translational motion into rotational motion. In pumps, compressors and other machines, rotational motion, translational. Gear wheels have been widely used in technology. They are used to change the angular velocity of the links. For example, when a large angular velocity of one gear needs to be converted into a small angular velocity of another. The angular velocity of the wheels can also be converted using various belt mechanisms with a flat belt, a wedge belt and a toothed belt. The ratchet mechanism is used to convert the movement of the input link into a periodic movement of the output. The Maltese cross mechanism can also be used for this purpose. Hydraulic and pneumatic mechanisms are widely used in modern machines. Such a variety of mechanisms allows you to create machines and devices for various technical purposes. The links of the mechanism are one or more rigidly connected solids that make up the mechanism. In lever mechanisms, one of the link sizes is usually significantly larger than the others. Often the links of lever mechanisms are made flat, having a constant thickness, but they can also have a complex shape. A fixed link in the accepted coordinate system is called a rack. Any link of the mechanism can be taken as a rack. Links of gear mechanisms, gears, various shapes and purposes. Cylindrical gears are the most common, forming teeth of straight-toothed wheels parallel to the axis of their rotation. In a bevel-toothed gear wheel, the teeth are inclined to the axis of its rotation. To transmit motion in space, conical gears with helical or straight teeth are used. The teeth of these wheels are cut on the surface of a round truncated cone. Movement in space can also be transmitted using a worm mechanism, which consists of a worm and a worm wheel. In some designs, non-circular gears are used. In these wheels, the teeth are cut along the surface of a profile made along a curve other than a circle. In a cam mechanism, the cam, when moving, drives a swinging or translationally moving pusher. The links of the screw mechanisms are a nut and a screw. In all these mechanisms, the links are solid bodies, they retain their shape in the process of movement. In temporary mechanisms, a flexible link is used, a belt. This link bends during operation. Different types of belts allow you to get a variety of mechanisms. Mechanisms with flexible links also include cable ones. A flexible link in them, metal or made of synthetic materials rope. Flexible link in the chain mechanism, sleeve roller chain. In hydraulic and pneumatic mechanisms, one of the links is liquid or gas. The link whose movement is transformed by the mechanism into the movement of other links is called the input. The link that makes the movement, for which the mechanism is designed to perform, is called the output. There may be several input links in the mechanism. In such mechanisms, the movement of the output link depends on the movement of the input links. One of the input links of such a mechanism can be used to regulate movement. When the position of the adjusting link changes, the stroke of the output link changes. The adjustment is carried out during the movement of the mechanism without stopping it. A link moving freely in space can make 6 possible movements. This is the translational movement of the link along each of the coordinate axes and its rotation relative to the same axis. Thus, a link free in space has 3 translational and 3 rotational movements, that is, 6 degrees of freedom. The connection of 2 touching links allowing their relative motion is called a kinematic pair. The kinematic pair provides from 1 to 5 links between the links. The number of connections determines the class of the kinematic pair. This is a kinematic pair of the first class of the type PP-BBB. It allows 2 translational movements and 3 rotational movements of the link. A kinematic pair of the second class of the PPVV type allows 2 rotational and translational movements of the link. Rotational movement relative to the third axis of the link is impossible, since the linear contact between the links becomes point-like. A kinematic pair of the third class of the PPV type allows 2 translational and 1 rotational movement of the link. A kinematic pair of the third class of the BBB type allows 3 rotational movements and is called a spherical kinematic pair. Such a kinematic pair is used in spatial mechanisms. A kinematic pair of the fourth class of the PV type allows 1 translational and 1 rotational movement of the link. It is called cylindrical. The spherical junction of the kinematic pair also belongs to the fourth class and allows 2 rotational relative movements of the link, and the kinematic pair of the fifth class of the type P, 1 translational movement of the link. In a screw kinematic pair, the screw turns, it moves along the nut. This pair is also fifth grade, it has only 1 possible independent movement. In fifth grade couples, contact between the eyes occurs on the surface. In rotational and cylindrical kinematic pairs, this is a cylindrical surface. In the translational plane. In spherical and spherical with a finger kinematic pairs, the contact between the links is carried out on a spherical surface. Kinematic pairs in which the contact between the links occurs on the surface are called lower kinematic pairs. In a kinematic pair of the fourth class of the PV type, the links contact at a point or along a line. Such pairs are called higher kinematic pairs. Lower kinematic pairs are usually used as guides of rotational or translational motion. They have a large contact surface and can take heavy loads without wearing out during operation. Higher kinematic pairs are used in gear mechanisms of machines and devices. They have a high efficiency, but they wear out faster than lower kinematic pairs. Links connecting with each other by means of kinematic pairs form kinematic chains. A kinematic chain in which there are links included in only 1 kinematic pair is called a simple open chain. In a branched kinematic chain, a link is included in at least 3 or more kinematic pairs. To form a mechanism, we close the kinematic chain and take one of its links as a rack, linking a coordinate system with it. Now we accept the link connected to the rack as the lead. To drive the manipulator of a modern robot, 2 cam mechanisms with translationally moving and swinging pushers are used. Which provides 2 grip movements. These movements are set by 2 cams. Only output links are specified in kinematic schemes of robots. The considered elements form the basis of all modern mechanisms and machines. A solid knowledge of them helps in the design and proper operation of new advanced technology.